Recall from the previous video that we are not allowed to have a square root in the bottom of a fraction. So last time it worked out just fine that when we split our square root, we had a perfect square in the denominator, so it wasn't a concern. This time, though, we can see that that's not going to be the case. We do not have a perfect square in the bottom. I'm left with a square root of 2, and that is not allowed. So we're going to use a process called rationalizing the denominator to simplify and get rid of our square root. So the way it works is figure out whatever that square root in the bottom is, whatever is causing you problems. And what you're going to do is you're going to multiply by that square root, but not just to the bottom, to the top as well. So I'm going to multiply the top and bottom of this by the square root of 2. Now the reason that's allowed is if I were to do the square root of 2 divided by square root of 2, or anything divided by itself, that's just a 1. So what's in green here is really just a 1. It doesn't look like a 1, but it is. And multiplying by 1 does not change anything. So I'm not breaking any rules. I'm following the math rules, I suppose. Nothing illegal is happening. I'm multiplying just by a 1. So watch how this process works. Since both numbers are inside of a square root, I just multiply them together. Square root of 5 times square root of 2 is square root of 10. And then along the bottom, same thing, they're both in a square root. Square root of 2 times square root of 2 is square root of 4. Okay, but I thought we were supposed to get rid of a square root in the bottom, and we still have that. But notice, we have the square root of 4, which is a perfect square. The square root of 4 is just a regular old 2. I've used the square root, so it vanishes. The numerator is the square root of 10. So I still have a square root, but it's no longer in the denominator, so that answer is considered simplified. Now some people want to go ahead and divide that. They want to say the answer is square root of 5. The reason that does not work is because the 10 is in a square root and the 2 is not, so we can't mix and match like that. We can't do a square root number divided by a non-square root number, so that doesn't work. We should also, though, try to simplify 10, like break it down into its pairs. So I have a 5 and a 2, but there's no pairs, so that can't be simplified. So this is as simplified as you can get. Same thing down here. Let's go ahead and split that first. So write it as square root of 25 over square root of 3. I'm noticing that 25 is a perfect square, so I might as well simplify that right away. Square root of 25 is just regular 5 divided by the square root of 3. Now, like we just said, that answer is not considered simplified because we have a square root in the bottom. So the way that we rationalize the denominator is multiply not just the bottom by that square root, but the top as well. Because really all that is multiplying by a 1, and that is a-okay. It does not change anything. In the numerator, 5 is out of a square root and 3 is in a square root. So they don't multiply like into a 15. The best we can say is 5 times the square root of 3. Just like, think of it as a square root as an x. So think of it as like 5 times x. The best you would say is just 5x. Same idea down here. 5 times square root of 3 is just 5 square root of 3. Along the bottom, however, those are both in a square root, so I can multiply them together and get the square root of 9. Our goal was to get rid of the square root in the bottom, and we can do that because the square root of 9 is just a regular 3. So there's my simplified answer. One thing you want to check for, always, another thing to check for, another way to simplify, is take a look at what fraction you have left over without the square root and see if that fraction can be simplified. 5/3 cannot be, so that answer is done. But suppose in just a completely separate problem, suppose you had something like square root of 3 over 3. In that case, if you look at your regular fraction, that could be simplified, and you would have to do it. So make sure you check for things like that, but that's just a side note. Okay, and then let's take a look at one more, unless you want to pause it and try it on your own. I want to multiply the square root of 5 in the top and the square root of 5 in the denominator because I want to get rid of that square root. As we discussed, along the numerator, those numbers are in and out of a square root, so I can't actually do anything with them other than say 5 times the square root of 5. Along the bottom, hopefully you guys have figured out the shortcut now. Square root of 25, or square root of 5 times square root of 5 is square root of 25, which is just a regular 5. The square root sort of cancels itself out when you multiply it by itself. That is not the final answer though, because as we just discussed, look at the regular fraction that's left over, the non-square root part, and simplify that if you can. That can simplify to just 1. So I can write that as 1 square root of 5 over 1, or just square root of 5.